All right. We should be live, I think. Hey, everyone. I'm going to talk like I think we're live. I'm going to assume we're live. We probably are. So welcome to the first of 4 episodes of Nerd Night Stream You in September. We all had a great summer. Summer is over. I'm sorry to inform all of you. It's now the fall. We're back to school. We're back to work. See you in September. All right, so what's going to happen? This is as I said, this is the first of 4 Nerd Nights every Sunday starting at 8 o'clock Eastern, 7 Central, 6 Mountain, 5 Pacific, and 10 a.m. Monday mornings for everyone in Melbourne and Australia right now. Most of the 16 presentations, there'll be 4 every night, half-hour blocks. And of the 16 total presentations, 13 or 14 of them are outer space themed. The great beyond. Woohoo! The reason that is that it's a long story, but we're supposed to have a couple of sponsors who have very deep space ties into this. We're trying to make everything align nicely. That ended up not working out, but we all love space anyway. So here we are because we're proceeding ahead because we're adventurers, we're explorers, we're the intrepid ones trying to see what goes beyond the world. So, so obviously we've got a number of people here logged in. Today we're going to feature folks from Nerd Night San Diego, Nerd Night Boca Raton, Florida, Nerd Night Melbourne, Australia, Nerd Night North Vancouver, BC. So everyone, wave, say hi, woohoo! It's an exciting. Some people are wearing pants from their homes. Some people are not wearing pants. That's up to you, the audience member, to decide and guess on your own who is and is not wearing pants. We aren't going to tell you. You've got to figure that out yourselves. Don't look at me, don't look at my pants, or maybe not my pants. Just a couple of notes for everyone watching. Obviously, you are all logged in Facebook. You have a lovely chat area there on the Facebook stream. Feel free to ask as many questions and make as many comments as you like throughout the presentations. As always, we will have about 8 or 9 or 7 or 6 minutes or so after each presentation to take a couple of questions for all of you. Why don't you all of you actually right now go ahead in the chat area, let us know where you are logged in from. As always, I'm coming from my apartment in glorious Brooklyn, New York. When we started doing these virtual nights, this was the epicenter of the coronavirus, which wasn't great. Fortunately now, sadly, New York seems to be leading the charge of mitigation, but that's not something to be proud of either. So, 2020. All right, I just want to mention 2 other things, that this presentation is being recorded. It will live right here on the Nerd Night Facebook page in a matter of seconds after we wrap up, so you can view this or tell your friends to view it as much as you like. And let's get out of the way here. You're not here to see me, so everyone who is not from Nerd Night San Diego, go ahead and temporarily disable your mics and your video. We want to learn a little bit about space here. So I'm going to turn this over to the Nerd Night San Diego folks, and we're going to learn a little bit of, as they're going to tell you a little bit about Nerd Night San Diego. And then we'll get to Gideon, who's going to talk about the hell up there. So Zed, Gideon, go ahead and take it away.
All right, thank you, Matt. Thank you. Hello and welcome from San Diego. It's such a pleasure to kick off this amazing event. I'm going to tell you a little bit about Nerd Night San Diego, but I don't want to take up too much time because we've got an exciting presentation coming up from Gideon Marcus. Nerd Night San Diego takes place every first Tuesday in a month, and it was founded in 2016. And so far, Nerd Night has hosted 43 regular events, and Nerd Night San Diego is still going on strong online since March this year, every month. And we've had some amazing speakers here on a variety of topics from about different types of science. And we also host Nerd Night specials. We had one on conservation, science, and comics. So we've got some super exciting stuff. We have a website, Nerd Night San Diego, and we have our own YouTube channel that you can also catch some of our past presentations. So tonight, I just wanted to introduce you to our first speaker. Gideon Marcus is a professional space historian. He's an award-winning science fiction author and Hugo finalist. Among many of his accomplishments, Gideon is probably best known as the founder of Galactic Journey. It's a time machine to 55 years ago that won the Serling Award in 2016. And he has been nominated 3 times since then for the Hugo Awards hosted by the World Science Fiction Society. He also founded Journey Press, which publishes Gideon's young adult space adventure Kitra, and Tom Purden's classic space opera, I Want the Stars. And one of my favorites, in 2019, Gideon edited and published a book called Rediscovery, Science Fiction by Women, 1958 to 1963, which is an anthology of some of the best works in science fiction written by women during Silver Age. It's our pleasure to welcome to the stage Nerd Night San Diego speaker Gideon Marcus.
Well, thank you very much for that. I feel like I should have 2 imposters to the side of me, and I'm at the beginning of the To Tell the Truth game show, which you probably don't know. So just to get right in, I am a time traveler, and as you can tell from the music, I'm actually from exactly 55 years ago. Courtesy of Galactic Journey, I live my life day by day exactly 55 years ago, and you can too if you go to galacticjourney.org. But in addition to my work as a time traveler, I am also a professional space historian, and today I'm very excited because I'm going to talk about possibly the thing I'm most known for and the thing I'm most passionate about, how we discovered the dangerous, lethal, horrible terror in outer space. So let's get right into it. If I can figure out slideshow. Hey, that's me. So we're going to start with this. Ordinary compass. So 100 years ago, we take a lot of what we know about the world for granted today in this modern day of 1965 or wherever you are. But just 100 years ago, we knew almost nothing about what was going on above the atmosphere in space. Sure, we had telescopes, but we were blocked by the atmosphere, which was covering up a bunch of wavelengths. We had no idea what the constituency of above the atmosphere was. We didn't know what the inside of the Earth was like, but we had some interesting ideas of what the Earth might be like. So for instance, we knew that when we had something magnetic, it tended to point certain directions. We knew there was a North Pole and a South Pole to our planet, which was interesting because what else has North Poles and South Poles? Magnets. That suggested that our entire planet, our spherical planet, was some kind of giant magnet. And maybe there was this molten iron core in the center of it spinning, creating this magnetism. But we didn't know because we didn't have the tools to know. It was a bit like trying to understand how the body worked without ever making an incision on it. And so we had to deduce from external effects what was going on inside the planet. One of the biggest external effects that we could measure was this. This is the aurora. If you're in the north, it's the borealis, and if you're in the south, it's the australis, which just means north and south. Now, these happen every so often, and what we discovered was these things tended to happen more often when the sun did this. That indicated there was some sort of correlation, which meant there had to be something that the sun was giving off that was somehow interacting with the Earth. And the Earth had to be doing something to interact with the sun to make the auroras happen. Well, what could it be? Well, we knew something about the sun about 100 years ago. We knew that the sun was composed of a very specific form of matter. Now, in school, we are taught that there are 3 forms of matter. There's solid, there's water, or there's liquid, and there's gas. However, those 3 common states of matter are actually the least common states of matter in the universe. Most matter in the universe is in a completely different state, I'm sure you know, called plasma. But it's not familiar to you unless you spend your entire life living in a fluorescent light bulb. Plasma is what happens when you have such energy that the electrons are stripped from the atoms. And you end up with this sort of free, gaseous kind of thing. It behaves like a gas, but it's completely different because now it conducts electricity, because it is electricity. It's electrons moving around freely, stripped from their ionic partners, the protons and nucleuses. And so what we figured is the sun was this really hot thing in the sky, 93 million miles away. And because of the great temperatures of what was going on inside, it was spewing off this plasma. And some of this plasma had to reach the Earth. And then when it got to the Earth must be doing something to this plasma to interact to create these aurora. Now, what could they be? Well, luckily, by the time we were very interested in finding this out, we had the tools to measure. So we determined around the early 50s that we would have in 1958 something we would call the International Geophysical Year. And this was a sequel to something that happened in 1931 called the International Polar Year. Now, the goal of the International Polar Year was not just to see how cold it is at the poles. Hint, it is very cold at the poles, but they knew that. But they were going to the poles because they wanted to measure these effects, and they were most pronounced. The aurora and the magnetic poles were most pronounced at both ends of the Earth. Now, by the 50s, they had a very special new tool to investigate what was going on in space. It was called the rocket. Now, of course, the rocket was not made to investigate space. It was made to put warheads on and blow up Moscow. Or if you live in Moscow, it was made to blow up Washington, D.C. However, the scientists figured we could put some scientific instruments at the top of these rockets, not shoot them at the other countries, put them in space instead, and measure what's going on up there. And so they did. Of course, we were not the first. The Soviets were the first with this little guy called Sputnik. And Sputnik did the tremendous accomplishment of going beep, 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 beep around the Earth many, many times, scaring us to death, but not actually returning a wealth of scientific data. And it was shortly followed by Sputnik 2, which carried a dog, but did not return a wealth of scientific data. It depended on this one before we got some really interesting information about what was going on in space. So this is Explorer 1, launched at the tip of this. You can't see my finger, but I'm actually pointing at it. This is the Jupiter C rocket. And the Explorer 1 went up on January 31st, 1958. And some very interesting thing happened. So this experiment at the tip of the Explorer, one of them was a Geiger counter. You're all familiar with Geiger counters if you've seen movies from the 50s and beyond. The little things that go clickety, clickety, click. They measure radiation. And the way they work is they have this tube full of gas. And whenever a radioactive particle, a high energy particle, hits this tube, it charges other things in the gas. These causes a chain reaction. All of these charged particles hit other ones. There's an avalanche, and this avalanche of particles hits a detector, and the detector goes click. And then it refreshes, it recycles, and then waits for the next avalanche to come and click again. And the more clicks you get, the more radiation you know you're detecting. The university which created this experiment was the University of Iowa, under the direction of Professor James Van Allen, who I've had the honor of meeting. And he had a lieutenant named Carl McElwain, who also worked with him. And we'll be getting to Carl in just a second. So they went up in space. This thing went up in space, in orbit, which meant it could do a long-term measurement of what was going on in space outside the Earth. Now, they kind of had an idea what to expect. They knew the sun was sending this torrent of charged particles and what we call cosmic rays. And the sun is not the only origin of cosmic rays, but it's the main one because it's right there. And we knew that as you went up higher in altitude, as the atmosphere got thinner, we were detecting more cosmic rays. We would send up rockets that would go up and then they come down. We'd send up rockets on balloons and they would go up and they would come down. And the higher they went, the more cosmic rays they detected. So we were pretty sure the higher you went, you would get more radiation. Okay, so Explorer 1 is going around the Earth, and sure enough, and by the way, this is James Van Allen in the middle, Carl McElwain to his right, and that is George Ludwig to his left. And I happen to know Carl. He actually teaches at UCSD. You can meet him too if you're in San Diego. He's a really cool guy. He's 90 years old. Well, to you, he's 90 years old. To me, he's 35, but he bikes everywhere. Just a great guy. So this is what Explorer 1 found. You see on the left, you get more clicks. Clickety, 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 click, 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 click. You get up to 600 miles above the Earth, and all of a sudden, the count went to 0. 0. That is not what they expected. 0. And yet, when the ship went down below 600 miles, all of a sudden, Geiger counter would be going like crazy. and slowly go down again. And this kept happening. Now, they were trying to figure out why this was happening. Well, there's a couple of reasons. Okay, one, maybe there's a spot in the sky where there's no radiation for some reason. That seemed dubious, but possible. Another is maybe their equipment was broken. Well, there's only one way to test if your equipment is broken. You send up an identical experiment. And that's just what they did. So they sent up Explorer 3. And Explorer 3 was identical to Explorer 1 in every way. And this time they kind of had an idea what to expect, because Carl McElwain said, I don't think our equipment is broken. I think it's actually detecting something that's happening. And I can tell you what, but let's see what happens with Explorer 3. And sure enough, Explorer 3 goes up to 600 miles, 0. Goes below 600 miles, the curve that they expected. And Carl McElwain said, aha, and everyone else said, aha, space is radioactive. Now, how do you think they determined that? Well, here's what was happening, or here's what they theorized was happening. It turned out to be correct. They were so confident they were correct, they announced it even before they had confirmation in April of 1958. I told you the way that these Geiger counters work. Particles come in, you get an avalanche, and it gets detected. The detector needs some time to reset, because what it is it actually detects flux, which means change in rate. And there was so much radiation above 600 miles that the avalanche would not stop. The instrument was saturated. And as a result, it just said, nothing's happening. I register 0. You deal with it. You're the scientist. I'm just a dumb machine. So that was pretty exciting. But they had to confirm it. So they sent up Explorer 4. And this one had a different radiation counter, one that was hardened to higher radiation so it could detect more, and also one of the old kind to act as kind of a control. Now, they were very worried, because if the radiation kept going up, then it might reach infinity at some point, and that's very bad both for satellites and for people, because if you go up in space and you get subjected to radiation for a long time, you are lucky if you come back as the Fantastic Four. Usually it's a worse outcome. All right, so they send up Explorer 4. It goes up. Sure enough, they are able for the first time to continuously map the Van Allen belts, or excuse me, this radiation effect. They just called it this radiation area because they didn't know what it was shaped like, what it did. They expected that it went on forever. And they weren't calling it after Van Allen yet, although that was short to come. They also didn't know what was causing this. So their first suspicion was, all right, there's all this radiation up there. The Soviets have been detonating a lot of nuclear bombs in the atmosphere because it's fun. And maybe this is where all this radiation is coming from. And how dare the Russians do this? How dare the Russians blow up bombs? When the Americans want to blow up bombs too, we're going to do it too. So we did, because we didn't want to miss out on the fun. And it was called Project Argus. And while Explorer 4 was orbiting the Earth in August of 1958, we were detonating nuclear bombs just to see what would happen. You know, like you do. Don't try this at home. I haven't done it for a couple of weeks, and after the cops caught me. So anyway. So sure enough, there was a relation between the atomic bombs and the amount of radiation. However, there was also a correlation between what the sun was doing, remember those flares, and the radiation counts. And not only that, even when the sun was quiet and we weren't detonating bombs, there was still this constant background radiation. Clearly, there was something circling the Earth, and it was a natural phenomenon, not caused by us. All right. Well, the only way you can find out what's going on up there in that hell is to send a probe all the way through it. And in October of 1958, we launched what was the most ambitious, important space probe to date, one that you've probably never heard of and yet was incredibly significant at the time, called Pioneer 1. Pioneer 1 was so important because at the time, the Soviets were beating the pants off us in terms of the space race. They'd beaten us with Sputnik. They'd put a dog in space. They'd made Sputnik 3, which was a very heavy spacecraft. It was as heavy as something that could carry a person. We knew that they'd have a person soon. They were rumbling about a moon probe. So we decided we were going to take some rockets that were on the shelf, put them on top of each other, make a big rocket, and send the first probe to the moon. And this one was made by the Air Force because NASA didn't exist yet. In fact, this probe was NASA's very first probe. It was an Air Force rocket, and they just painted NASA on it right before launch. That's how rapid this thing was put together. So Pioneer 1 goes up, by the way, carrying the exact same experiments that were on Explorer 4, which means Carl McElwain is back in the story again. Pioneer 1 makes it halfway to the moon. One of its rockets doesn't go off, and then it comes back down. And you might say, well, that's a failure. Well, except no one had ever gotten a rocket halfway to the moon before. And all along the way, its Geiger counter was going clickety, click, 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 mapping this belt of radiation for the first time. And what it discovered was that this radiation stopped. It went up higher and higher, and then it went down. And everyone back on the ground breathed a sigh of relief, because if you could get past this belt of radiation, which they now knew was a belt and not an eternal zone, it meant we could get people in space. It meant we could put satellites below and above it. But we still didn't know very much about it. So here's Pioneer 3, which launched in December of 1958. And this was an Army probe. You'll notice it looks very similar. This rocket at the top looks similar to the one that launched Explorer 1. Same team. This is the Juno 2 rocket. That was the Juno 1 rocket. So this was another moon probe made by the folks at JPL across the LA County from STL. They had a friendly rivalry going on, sometimes not so friendly. And Pioneer 3 also didn't make it to the moon, but it went pretty far, and along the way it discovered there were not one, but two Van Allen belts. And that was pretty exciting. We were now starting to map the topography of this radiation belt in just 1 year from conceptual to actual mapping. And as of the beginning of 1959, this is what the Van Allen belt looked like. Now, we didn't know what the other side looked like. We only knew what its general configuration was in one direction. We had an idea that it went all the way around the Earth, but we only had a couple of probes checking it out. What this did conclusively prove, though, was that the Earth is magnetic in some way. But how did it look? So the Russians sent 3 probes to the moon. We sent up Explorer 6, we sent up Explorer 12, and we started doing comprehensive mapping. We were no longer doing flyby pioneering flights. These were ships that were in space to stay. And we found out that the Van Allen belts look like this. This is by 1961. We had a pretty good idea of what they look like. And anyone who's taken high school physics knows what this is. This is a magnet. You ever take the bar and you put the iron filings on? Does anyone have a use for iron filings other than this experiment? Is there like, did they adapt iron filings for this job, or were they just made for this? Is there an iron filings factory? I've always wanted to know these things. Please tell me if you know. Now, one thing that's interesting about this, you'll see that this magnet, this field is not symmetrical. So you'll see on one side, you've got this bow shock, and that's because the sun is shooting this stuff at the Earth constantly and pushing it back in what's called a bow shock. And this trails back on the other side of the Earth. Pretty neat. So this is also 1961. We knew enough about it that we could do these official NASA graphics. We had an inner Van Allen belt and an outer Van Allen belt, and Van could not get away from the fact that his name was now stuck with this deadly radiation belt. We were very happy that it wouldn't go on forever. We knew that people could go to the moon, but these things are pretty thick. Now, how many of you people out there know some moon hoaxers? I understand 1 in 6 people is a moon hoaxer. They believe we never went to the moon. It's impossible we go to the moon. First up, you see the flag doesn't move, and it makes, and there's a shadow, and right. They all talk like that, by the way. It's a congenital defect. One of the things they talk about is it's impossible to get to the moon because the Van Allen belts will fry you to death. And they have a point as far as it goes, which is the Van Allen belts are very dangerous, and not just to people, but to satellites. If you put a satellite where it intersects with the Van Allen belts, you will have problems, and they're twofold. One is general. Radiation hits the satellite, it eventually will fry components because you have these high energy things banging into the satellite. And the other problem you have is with a satellite is now that they're digital, even by the early 60s, they're digital components. You will have these radiation, these highly charged electrons and protons hitting components, making spurious 1s and 0s. Well, 1s and 0s are the only data that you have. And so when these things hit, you're ruining the data. So there's ways around it, right? You can make satellites that are heavily shielded, which is heavy. We don't like heavy. You can make satellites with redundant components. We don't like that because it's heavy. You can make satellites with automated checksums. So in other words, they say, look, I'm going to total up 10 numbers. I expect a total that has a 0 or a 1 at the end of it. If I have something different, I'll run the calculations again. So these are not unsolvable problems. And that's important because while the bulk of our satellites live below the radiation belts, lots of them, like this synchronous orbit SYNCOM, which means it stays in one space above the Earth from our perspective for 24 hours because its orbit is 24 hours. And this is about 22,000 miles above the Earth. That's smack dab in the middle of the Van Allen belts. So it is true, being in the Van Allen belts can cause problems, and we've have had to work with this. So how do we get to the moon? Well, it's interesting. You don't have to live in the Van Allen belts for two reasons. One, this is the flight plan of Apollo. You'll notice that it is angled such that it only briefly goes through the thinnest part of the Van Allen belts. So the exposure is limited. For another thing, you're not staying there, you're just going through it. And here's a third thing. It is actually less harmful to have more radiation for a short period of time than less radiation over a long period of time. So for those of you thinking of getting x-rays and regular checkups, I recommend that you get 100 x-rays tomorrow rather than spread them out over the rest of your life. You might not detect as many things, but you will be safer from cancer. You got that from a person who is not a doctor, nor do I play one on television. All right, now from here, so this, by the way, this lets you know that yes, we could go to the moon and not be fried by the Van Allen belts. That's important. And if anyone ever comes up to you and says, but the Van Allen belts, and people still will, you can say, here's this picture that I was shown by a man who's not a doctor, but he is a time traveler, and therefore I know that you are wrong. All right, now, because I'm a time traveler, I'm going to go to my future, which is close to your present. When I first created this presentation last year, and when I did, I was, I'm a big space buff. Granted, I know more about 1965 than anything else, but I've known about space probes, and I looked into what space probes we had used to analyze the Van Allen belts, and oh my goodness, there are a lot. I know you're all probably excited about Elon Musk and Starship and Dragon and the International Space Station and the fact that we're going to go to the moon in 10 years, which we've been saying for 20 years. But what the heck? It's going to happen, right? I know you're excited about that. Go to NASA's website and look up their active satellite missions, because this is where the excitement is. And by the way, Professor James Van Allen was a much bigger advocate of robotic space probes than human space probes. It's cheaper, faster, and better. So this is a space mission I didn't even know about until I did the research for this talk last year. These are a pair of Van Allen probes launched in 2012. They went silent at the end of last year after an unprecedented 7 years mapping the Van Allen belts. And it is crazy how much we have learned about the Van Allen belts by having space probes monitoring them and doing nothing else with their lives for 7 whole years. So for instance, we've learned that the Van Allen belts are not perfect donuts. Did I say, no? Do we have donuts? I'm sorry, I got distracted. Donuts. They're not perfect donuts. They have pockets, they have discontinuities. And this is important because places where there's less radiation are places that you want to park your satellites or send people through. But another thing they learned is you see how it's round. And because these are charged particles, they carry a current. There's actually a ring current that goes around the Earth. That's what it's called, the ring current. And it is composed of both protons and electrons. And what we thought was these were dependent on the sun. We thought that for 50 years. Turns out we were wrong. This is true of the high energy protons. Sorry, of low energy protons. Those are sun dependent. But the high energy protons are always there. They're always living there, creating this current. We didn't know that before. So we are still discovering the stuff about this amazing hell up there, this radiation belt that is such a characteristic part of our near Earth environment, even 60 years after all this stuff I'm telling you about. And what's super cool about this is also, of course, telling us about what's going inside the Earth, because if we know what the magnetic field looks like outside, we have to know something about what's going on inside the Earth. And I know we have a geologist who's going to be talking later today, and I would love it if he could somehow tie in with this, because I'd love to know what we've learned about geology from these Van Allen belts. So anyway, this is normally a 35-minute time. I have taken a lot of amphetamines to make sure I could deliver this to you in 20 minutes of time, because I'm told you want to ask questions. So I will just leave you with this. Not only do we know about the Earth because of this, but this has also taught us a lot about what we can expect in other planets and planets around other stars, of which we know there are thousands and thousands, and they're probably universal. So the Van Allen belts, they're really cool. And I'm happy to talk to you about them or early space flight or anything else. And while you're at it, if you like this talk and you like subjects like this, go to galacticjourney.org, where every other day we come out with an article on either science fiction or science fact. We have covered pretty much every major space flight, including Gemini 5, which from my perspective just went up for 8 days in space. We also cover music and movies and politics. I know we are not supposed to discuss politics, so I will just say that I hope I don't offend anyone with my current voting preferences. So now you know how I voted in 1964, but I don't think there's a lot of Goldwater fans. All right, so bring on the questions.
Whoops. All right, Zed, you can hop in if you have any. I'll grab one from the chat area. Gideon, we want to know, are all satellites in geosynchronous orbit in the Van Allen belts?
Yes.
Great.
Strike that. Yes, they by definition, because the Earth is rotating, they're rotating. While there are parts of the Van Allen belts that they are weaker above the poles, of course, as I showed you. If you want a geosynchronous satellite, by definition, they have to be in the east or the west, which means they're smack dab right in the middle of the Van Allen belts.
Right. Second question. What is your favorite moon conspiracy theory?
Do I have to have a favorite one? I think my favorite moon conspiracy knockoff was when Buzz Aldrin punched that guy in the face.
You do have to have a favorite one. You are that's written in your contract.
It's written in my contract. There has to be consideration in any contract. I went to a year of law school, and until I get paid. Actually, I do like moon conspiracies because they teach you critical thinking. And I think my favorite is talking about the shadows on the moon and how there's all these different ways that the angles went. And they teach you actually a lot about how lighting works in space. And that's really cool. You can actually learn a lot about astronomy in all the debunking of the moon conspiracy theories.
Great. One more, I think. On a second, watching. Sorry about hands. But I'm trying to maneuver a very old, antiquated laptop with a phone and moving some things to maintain virtual eye contact. It's vexing. I would like to know, have astronauts given any specific feedback about the Van Allen belts while either en route to the moon or on the way back?
No, not really. Certainly not that I'm aware of. Although, remember, I also live in 1965, and the furthest we've gone up is about 500 miles above the Earth. So almost every...
Right, that is true.
Well, and this is important, almost every bit of astronautical activity, with the exception of the Apollo missions, which for me are coming up in a couple of years, have all been below even the inner Van Allen belt. And the Apollo astronauts necessarily went through them very quickly. And by that time, we already had plenty of probes that were collecting data. So it's not like Neil Armstrong had to be there with a Geiger counter and say, yep, there's radiation here. And oh, I guess I'm not having children.
Right. All right, last question, and we will get to Nerd Night Boca Raton in 30 seconds. Does the Van Allen belt change when the poles switch?
They must. Now, we have never witnessed it, but the reason Van Allen belts exist is because there are magnetic fields in space, and magnetic fields trap electrons and trap charged particles. They can't help it. So once the poles switch, necessarily the Van Allen belts must switch configuration as well.
Great. All right, so everyone watching on the internet, give a big virtual round of applause to Gideon from Nerd Night San Diego. Woo! Yay, virtual round of applause. Zed, any remarks to play him out?
No, I think we're running out of time. We're happy to, that was an excellent presentation. Thank you, Gideon. Check us out on Nerd Night San Diego. We're virtual every first Tuesday in a month at 7 p.m. Pacific time. So tune in, we're on Zoom, we'll be sending out the link. If you sign up on the Facebook event page, we'll send you a private link and you can come and nerd out with us. Thanks so much. Thank you, Gideon.
Thanks, everyone.
Thank you,
all right, I'm gonna get out of the way. Let's turn this over to sunny Southeastern United States. Nerd Night Boca Raton, take it away.
Okay, thanks so much, Matt. That was an awesome presentation there, Gideon. That was fantastic. I'm a huge fan of the flux. I could tell you that. But my name is Troy Bernier, and I'm with Nite, Boca, Raton. Just a little bit of history about us. We were very new on the front of Nite. We've had about 20 talks, roughly, and many of our talks were leaning towards history, science fiction. We had huge contributors of the Miami International Science Fiction Film Festival, played a huge role in a lot of our talks. Myself, I'm a geologist. I'm a geologist, a geoscientist, water resources, hydrology, all of those cool things that I love to participate in and work in. And I'd like to introduce everybody to Miss Judy Wilks. Ms. Judy Wilks comes to us with a very interesting, strong background in science and engineering. But her background is in the aviation, aerospace operations. She's currently a project manager with the National Grid. A lot of folks in the Northeast may know National Grid, that used to be Con Edison. She also has considerable experience with avionics design, aircraft manufacturing. She's participated as a project engineering consultant for the launch team of Canadarm with the Canadian Space Agency, who was responsible for the arm on the International Space Station. Judy has a continuous desire to expand her aviation, aerospace knowledge in her career. She's also a member of the National Society of Black Engineers and is working on a lunar colonization project. So a spinoff of this colonization project, she brings us a talk today, a discussion on the different theories on the formation of the moon. It's all yours, Judy.
Well, thank you very much, Troy, for that introduction. I am honored. Thank you very much for asking me to join you all to participate in this wonderful talk, and I look forward to hearing your questions. I should say good evening to the folks in the East, good evening to the folks in the West, and good morning to Melbourne, Australia. So greetings. So let's get started. Let me get my screen up for everybody. Oh dear, we started with the trouble already. Here we go. Thank you very much. So let's go. Well, first question we always ask ourselves is, what is it about this moon? What is it about the moon that captivates us? And for centuries, the situation has been said to be romanticized, fantasized, and dramatized. We've also done tales, like stories and nursery rhymes about it, as well as walked on it and studied relentlessly to this day. And with this—
Oh, wait, hey, Judy, sorry, let me interrupt for 1 second. We're not seeing you. Could you just stop your webcam for a second and restart it just so we can get the full experience?
Stop my webcam for a second, sure.
Yeah, thanks. Sorry about that. Just want to make sure we all got it. It was weird. You were on a second ago, and then we lost you for some reason.
How did you lose me?
I don't know.
Lost in space. Here we go.
Yeah, it's stuck on me.
It is stuck on you.
You're stuck on me, Matt. It looks like I'm pinned. Somehow I'm pinned here. I don't know how that happened, but I'm pinned.
Okay, how's that?
There we go. All good. Sorry.
Okay.
Thanks, everyone.
All right, I'm playing hide and go seek. We're playing Peekaboo. Let's go.
And then you can share your screen.
Let's start. So as I said, we had many conversations about the moon in many different facets, from movies to books and so forth. So when it comes to finding the history of our moon and the history of the background regarding where we come from, we have to ask ourselves, like we do for our own selves, our own families, we always ask the question, where do we come from? For us, as humans, we have the family tree. We could go through the background by asking our parents, by asking our grandparents, hearing different stories and so forth. But unfortunately, when it comes with the moon, that is not as easy. But for us, we could go ahead and do so, for example, by making these inquiries, like from the many episodes of Star Wars, we have basically the family tree that we know where everyone comes from, the good, the bad, and definitely the ugly. But nevertheless, I digress. So when we come to the moon, we have to ask that question. Where did it come from? How did it get into our solar system? Well, scientists have basically have said that there are some theories or hypotheses that comes to light. So we have to look at it from different angles. So the challenge is we don't have ancestry.com or websites like 23andMe, for example, to discover where it comes from. And thank goodness for the Apollo mission, we have the moon rock samples to help us, guide us, to give us some ideas. But unfortunately, it does not come that simple. We still have questions where we still need to look at it. So its origin has gone through a series of debates that has resulted in, resulted in the development of a few hypotheses. The first one is the capture, the second is the co-formation, and the last being the mega impact, or otherwise known as giant impact. I'll go through all three of them, touch on them very briefly. For the first one being the capture theory basically focuses on the concept that the early moon was floating through the solar system and got captured by the Earth's tidal force. And with that capture, it brought it in within its orbit, and the two have been working together synchronously. The other option, which came into mind, was also known as co-formation. The co-formation theory behind this is that the early Earth and the early moon were formed side by side in the same protoplanet disk, dust and gas cloud. The theory is thought about a Darwinian concept as how the solar system was developed. So it got transferred over to the co-formation, thinking the same thing must have happened for both the Earth and the moon. Well, as time has progressed over the last 80 years, it comes to mind that the late 70s and 80s, theories and thoughts had changed. And with that thought and change, they had a conference in 1984 in Hawaii where the new hypothesis called the giant impact or mega impact was discussed at length. And with this, it basically wants to say that the moon and the Earth collided. The early moon was considered Theia. It came across the solar system and hit the Earth, not at a center, but an off-center piece, ricocheted back, and the dust that formed and the rock and dust that formed went into unison, and while they were moving around at rapid rates, was able to form themselves. So with that said, I have an example of a little video as to how this transpired. I'm praying that this works right now, and of course not. Pardon me. Anyway, unfortunately, my video is not going to work, so we're going to continue on. So with respect to that concept, I'll go back here, where the moon and the Earth colliding, and they made all this dust, and they worked in unison to form over millions of years. Then we came to the other conversation as to what the truth behind it, and if it has any weight. With the capture hypothesis, for example, as I said, the early moon was formed elsewhere and captured by the early Earth's tidal force. But unfortunately, when we compared the information with the giant impact, the early moon and the Earth both share isotopic compositions. Those isotopic compositions consist of oxygen or various forms of oxygen and titanium. The problem with the capture hypothesis is that the question comes up as to how did its very unusually wrong, funky shape formation of a rock became spherical? Most of the times we'll say it's gravity. It does that on its own, which makes sense, yes. Then there's also the other problem where we notice that the two astronomers may not be worried, that may not work. And also the next one was the moon and the Earth size ratio is too high. So that was basically discounting the capture hypothesis. The next one would go with formation. When we talk about co-formation, again, remember, we just said the Earth and the moon were formed side by side. True. However, if they were formed side by side, would they not have similar composition? Yes, no, maybe so. But if they did have the same similar composition, wouldn't their densities also be somewhat identical? Unfortunately, identical. So unfortunately, that hypothesis has been debunked. So when we move forward with the giant impact, a lot of research is continuing on with regards to it. And despite that, we have some arguments still going on saying that the giant impact hypothesis may not be the end all and be all or the true hypothesis. So we're still going to continue on with the research. The argument basically starts on, the concentration of iron between the Earth and the moon. And most likely the moon doesn't have all the significant heavy metals that the Earth has. So they want to say, how is it that the two came together? There was also another concept where they're saying, if you look at the Pacific Ocean basin, there's such a deep indentation, that's where the moon came from, where it impacted and left. We don't know. We still got work to do. So with that said, but there's a lot of renewed interest into there's still a lot of renewed interest to returning to the lunar surface. The main objective here is to learn more about our moon. As recent as 2018, here's a few examples of some papers discussing the formations and the antidotes and the different theories and studies that will be conducted. And with that being said, I look forward to seeing how these theorems, these actions, and these different practices will be introduced to finalizing if the giant impact hypothesis does turn into an actual theory. Thank you for your time, and I look forward to hearing your questions.
Okay, can you show us that video? Can you share the video?
Sure, I will go through and see if I could pull up that video. Here we go, there we go. Here's the video I was referring to.
Share your screen. You have to share your screen.
Am I sharing my screen?
We haven't seen the.
All righty, technical problems. Oh, there we go. You gotta love technology. Here we go. So as I said, here is the Theia moon, basically crashing into the early Earth. When the two collided, the explosion of rock and dust and formation that goes on. Then we have the, as I call it, the dance of the dust, the dance of the gases, and the formations begins. So I would say, I heard this line said, what would be, imagine what this will be when if you were standing on the early Earth and seeing this moon rising up over the horizon. That is so absolutely breathtaking. So this is possibly what it could have looked like as they continue to generate to what we have today.
Wow, that was pretty neat. I like that animation. We did have a few questions. One of the questions, under the giant impact hypotheses, this comes from Nirav Agarwal. I hope I pronounced that correct. Under the giant impact hypotheses, how long did it take for the Earth and the Moon to get to their current orbits?
Well, right now the timing says it's over a series of 14 billion years or million years.
Oh, that's a long time. That's a long time.
That's a long time. Honestly, I will need to check the dates because there is conflict in terms of the timing. Some say billions and some say million. So once I find that out, I will hope to let you all know, because I like to know too.
Well, also, I could say there was one more question. Actually, there's a couple, but one of the other questions is, how long has the moon been tidally locked? And I can definitely say, folks, the moon it does not stay at the distance. It's not a constant distance. And you want to enlighten a little bit off us on that, Judy?
Well, it's not a constant distance because as it stands right now, according to my last bit of research, the moon is moving away from the Earth approximately 3 meters a year. So, but it's still with us. It's been tightly, again, the time frame is around, this is my layman's view of calling it. I would say since before the dawn of the dinosaur. So it's been around for about, I would say about 5 million years they've been tightly locked. But again, I need to check those dates because everything keeps changing. Trying to get the total age appropriate is what's been the conflict, but I would say about anywhere between 5 million to about 10 million years.
Okay, one more question here. What do we think about the November 2nd potential impact?
November 2nd potential.
I think the question is coming from, so there's supposed to be an asteroid or a meteorite or something coming relatively close.
That one, right.
November, early
Well,
November.
I don't foresee it happening. If it does, we'll all find out. If it doesn't, we'll all find out. We were hoping to have at least the opportunity for the space mission to the asteroid and meet it and examine it and test it. But with all the changes that goes on, we could just hope for the best right now. This is the layman's side talking. We just hope for the best, that it bounces off our atmosphere and keeps on trucking. But if that's not the case, well, we'll find out.
Last question. Someone is asking, where do you think that that object that became the moon, where do you think it came from?
From some other solar system way across. I don't know. Personally, I don't know, but I really like to know. I couldn't really tell you, but I would like to know as myself too.
Okay. All right. Well, I think that's it for our questions, unless there are any more. Any more questions out there, folks? I think we could take one or two.
It looks like the consensus is that it's 2020. So, we have that 1 in 210 chance of it happening. It'll probably happen.
And when it does, we'll all find out.
That's exciting.
Maybe not. Maybe not.
Well, hopefully on the bright side is that it's supposed to be about 6 feet long. I am exactly 6 feet long. So maybe if I just jump onto the ground, that'll be a good test case to see what happens. Although I will admittedly be going at 0.5 mile an hour instead of hundreds of thousands of miles per hour.
There you go. Yeah,
there you go.
This is a small
thing. Experiment.
And for all we know, if it's only 6 feet across, for all we know, it could burn up on the atmosphere before it even gets to us. So,
yeah.
God willing.
Hopefully.
Cool. All right. Thanks so much for joining us from sunny, though now dark, South Florida.
Well, actually, I'm in Massachusetts and Troy's in Florida, but from the East Coast.
Right. Sunny/dark Massachusetts. I apologize.
No trouble.
Cool. All right. Okay, everyone. So we've got about 3 minutes until our next presentation. Let me just do a couple of things behind the scenes here to make sure we're ready to go. I've got a couple of announcements to make in the meantime. So first of all, I want to let all of you know that if you are interested in buying a fantastic t-shirt during the pandemic, like I am wearing, or a sweatshirt or something else to show off your Nerd Night pride, go to nerdnite.com and you can do that. That will, luckily for us, that will earn Nerd Night ones of dollars. Obviously, we haven't been able to hold any face-to-face events, which is the only way that Nerd Night makes money. We haven't been able to do that since March. So, any ones of dollars that we can make would be greatly appreciated. And if you're so inclined, if you go to PayPal, not Venmo, because, it's Nerd Night, we're still stuck in 2004. If you want to make a donation, just donate to matt@nerdnight.com. I promise that is the official Nerd Night corporate account address. I will not be using it to embezzle it myself to buy any N95 masks or to take a vacation, because I'm too scared to take a vacation still. For any of you who are from the New York area watching right now, the surprising news, which is both good and slightly disappointing, is that we are actually supposed to have a live event 5 days ago. Here in New York, since we've been, since it's been doing pretty well, relatively speaking, to at least the rest of the US, but not the rest of the world, there's our venue here in New York, even though it's an indoor venue, it actually has a lot of outdoor space. It's sort of a sister venue that opened up last year. So we actually, before I could announce it, we had an event on the books for last Tuesday, September 1st. And literally the day that I was going to announce it, to say, hey, we can have a limited capacity outdoor event at night, the New York State Liquor Authority decided specifically that outdoor events that involve somebody talking into a microphone are not allowed right now, which was very strange. That also included stand-up comedy, but it did allow for things like bands to perform. So it's very confusing. We're trying to follow the law, but that one seemed kind of weird, that somebody literally just talking at a normal voice, normal loudness, speaking into a microphone is no longer, is not permitted in New York, whereas a band or someone screaming into a microphone is permitted. So, everyone's making up as we go along. We're trying to be safe, but yeah, we almost actually had a live event in New York. It would have been crazy. So who knows when that's going to happen again. For everyone watching, as a sort of serious public service announcement, I know that every venue that I'm aware of in North America is still not permitted to have live Nerd Nights. We had a Nerd Night live in Bratislava about a month ago, so that was exciting for all of you out there in Slovakia. So if possible, a lot of smaller venues that have been really impacted by this, that have typical events like Nerd Night or other things, have been obviously very adversely impacted now, not being able to have events for 6 months. So if you are in the mood for donating, donate to those small venues. They're all on their last legs at this point, including the one in New York. And obviously the performers who do events at those are also in trouble. So hopefully, I don't know, there may be a vaccine, there might not, but frankly, at this point, I'm certainly pulling for one because just for selfish reasons, just so we can get back, but also to living sort of normal lives. So anyways, enough about that. Let's get back to other cheery topics like other ways that the world might end, which leads us to Australia. So Doris, Mark, go ahead and fire up your webcams and your audio there. So obviously for most of us here in North America, it is Sunday night, but for our friends in sunny southeastern Australia, this is like a time machine. It's already, they had Sunday night 14 hours ago. So, you know, they get to relive Sunday night all over again. Now they're in a perpetual time warp. So our next presenter this evening is going to talk about possible ways of having cataclysmic earth-ending events. So that's uplifting. We're trying to keep everyone very uplifted here tonight. And just as a fun random side note, as some of you know, in my spare time over the last month and a half or so, I started a podcast because, you know, what the world needs right now in the summer of 2020 is another straight middle-aged white guy starting a podcast. That works always really well. So I started a podcast in early mid-July about called the Nerd Night, called the Wallet Voyeur Podcast. And what that means is that it's an interview series with people talking about their salaries, about how much money they make specifically, because, you know, it's scary to talk about how much money we make, but, you know, it's good to have salary and income transparency. Makes the world a better place. And Mark, who you'll be seeing in a couple of seconds, to learn about cataclysmic events. He was a good sport and actually was one of the third or fourth episodes of the podcast. And if you listen to it, you can find out how much money Mark makes. You'll feel a little, you know, dirty about it, but you'll also be more informed. So with that, Nerd Night Melbourne, Doris, I think I enabled your video. So you should be able to have it now. Go ahead and take it away, and let's hear from Melbourne. So Nerd Night Melbourne, go for it.
Hello, everyone. My name is Doris Toe, and I'm representing Nerd Night Melbourne in Australia. Well, we hosted our first event in the city in September 2013 and usually run about 6 events a year. You can find us on Facebook by searching Nerd Night Melbourne. Our most recent event was held in February before Melbourne went into lockdown. However, we're really looking forward to seeing everyone again when we're back. In fact, we have Mark Richardson, who presented at our February show with us today. Mark has also since joined us as a Nerd Night Melbourne boss. Well, let me introduce Mark Richardson. Mark is an early career researcher, currently working at Australia's National Science Agency. He is an optimistic nihilist and absurdist and welcomes you with open arms to his island of existential terror. Mark, over to you to tell us about the second law of thermodynamics and other civilization-ending catalysms. Mark.
Thank you, Doris, and thank you, Matt. I'll just get you guys to confirm for me that this screen share is working okay?
Yeah, all good.
Yep.
Wonderful. Okay, yeah, good morning from Melbourne. I hope everyone is staying safe and healthy. And on the topic of health, I do want to issue a trigger warning with this presentation. You know, I understand that it's a stressful time and anxiety and depression at all-time highs. And some of the things that we're going to be discussing here are potentially upsetting. So, you know, in short, I will be discussing human extinction over the next 30 minutes or so. And if you think that, you know, maybe you're not in the right headspace to listen to some of this, then, you know, by all means, just tune out for a little bit. At the same time, I do want to reassure anyone who does decide that they want to continue watching that this is meant to be informative and entertaining and interesting. So it's not all doom and gloom necessarily. But yeah, if you feel like it's all right for you, no hard feelings if you decide to tune out for a little bit. But if you have decided to stick with us, I'm going to assume that I have your consent to get a little existential. I'm going to be presenting the second law of thermodynamics and other civilization-ending cataclysms. So as the title implies, this the first part of this talk at least is going to have a little something to do with the laws of thermodynamics. There are actually 4 laws of thermodynamics, but they're numbered 0 through to 3 rather than 1 through to 4. The reason for this is that the first 3, so laws 1, 2, and 3 were sort of entered into the lexicon, the scientific, standards, and it was realized only later on that actually the what we now call the 0th law, which helps to define temperature, had actually been left out by mistake. So even though it only goes up to the 3rd law of thermodynamics, make no mistake, there are 4 of them. But for the purpose of this talk, we only need to talk about the 2nd law of thermodynamics. And there is a concept that is really key to the 2nd law, which is something to do with entropy. Now, entropy is something that you may or may not have heard of before. And we're going to talk about it in 2, what I think are going to be intuitive models. So the first concept in entropy is that energy has a tendency to spread itself out as thinly as possible. We can consider this in sort of real world familiar situations. For example, if you boil some water and then pour it into a cup, and then you just leave it in the environment at ambient temperatures, something is going to happen to the energy that's contained inside that glass of water. Over time, the temperature will eventually drop. Now, real world situations are actually extremely difficult to explain, and so we're going to move to a simpler explanation in just a second. But what I want you to appreciate about this is that the energy can't disappear. There's another law of thermodynamics that says that energy cannot be created or destroyed. And so if we think about the temperature associated with this glass of water as being a type of energy, then it can't just be reducing its temperature for no reason. There has to be something driving it, and that energy has to go somewhere. The problem with this as a real world situation is that there is an enormous complexity. We have to get lost in the minutia to try and explain what happened to that energy and where it went. So even though this is probably the most intuitive example, I'm going to move to something a little bit more abstract now so that we can intuit through it a little bit more easily. So here are 2 hypothetical objects. We're going to assume that they're made of exactly the same material and that they have exactly the same dimensions, they're the same size. And we're going to now bring them into thermal contact. Now, even though these objects are identical, one of them is actually a little bit more energetic than the other one, and that's because it has a higher temperature. So the red block here, we're going to say is the hot object, and the blue block is the cold object. Now, as we bring them together, something's going to happen. We know that from our experience in the world, that the cold object is going to warm up because it's now in the presence of something hot, and the hot thing is going to cool down because it's in the presence of something cold. But where does that end? Maybe this is something that hasn't occurred to you before, but they have to get to the same temperature if they are the same material. And once it gets to that stage, the flow of energy, or at least the net flow of energy, comes to a complete stop. So now think about something else to do with the system. Have you ever seen that process happen in reverse? Have you ever seen a cold cup of water suddenly become hot? Or have you ever seen water on the bench suddenly sort of get cold and freeze? You've never seen this because it is a one-way ticket. Energy spreads out, it never accumulates in one place for no reason. This is actually a really profound situation. All of the laws of thermodynamics, sorry about that. All of the laws of thermodynamics generally happen in a time directional sense. So if you think about Newton's laws of motion, for example, if someone was to show you a slideshow of a projectile being fired out of a cannon, for example, you wouldn't actually know whether or not that slideshow was being presented to you forwards or backwards in time because it looks the same. So we're going to move on now to the next part of this presentation, which is not just that energy spreads out, but that chaos is inevitable. Chaos is another element to entropy. And there are some beautiful animations here that I've actually borrowed from Moby Motion. So these towers, I want you to think of them as representing structure. They're composed of individual pieces, and each one of those pieces has a particular place within the tower that it's supposed to be. But there are also so many ways that we can distribute these pieces that don't result in a constructed tower. So if there's one way for the tower to be built, there's actually an infinite number of ways that the tower can be unbuilt. And by sheer statistics, that means that there should be a 0% chance that a tower can remain built if it's allowed to equilibrate between all of those different arrangements of its pieces. You actually fight against this every day of your life. Maybe you have a pile of clothes on your floor at home that you haven't yet put away. The reason for that, maybe, is that there is only one place in your house where the clothes are supposed to be, but there's an infinite number of places in your bedroom where the clothes could be. And so it actually takes energy, it takes time and effort to fight against that chaos that's constantly working its way into your life. Now, the reason why this is important is that similar to the hot thing distributing its energy out into the environment and cooling down over time, the same way, these towers are distributing their organization, they're distributing their structure, so that over time they also dissipate and become more chaotic. So these two principles, the fact that hot things tend to cool down and that organized things tend to become disorganized, these are the things that give time a direction. Without these things happening, time is actually a directionless concept. This is important because the universe is currently in that situation where it's still cooling down or still falling over in the case of the tower. About 14 billion years ago is when our universe started to fall over, it started to cool down. On the other side of that, there was a stage of perfect order where the universe was very, very organized and probably very, very hot. And at that point, because nothing's changing yet, there was actually, there's no way to talk about time. So you might hear physicists and philosophers talk about before the beginning of the universe as not having any time associated with it. Because if each second is identical as every other second, then it's actually impossible to establish a reference frame by which change occurs. And so there is no formal time associated with that point. There's a problem though, and that's that this timeline is not infinite. There will come a stage in about 1 to the 100 years or 10 to the 100 years from now, where the universe is finished falling over, where those animations of the towers distributing their pieces on the floor eventually comes to a rest and they never rebuild themselves. We call this the heat death of the universe or the cosmic time limit. At this point, all of the radioactive decay of atoms has completed, and the universe is an infinitely sparse, warm soup where nothing ever changes and it never has any structure. And because there is, this is the other extreme, so where if the beginning of the universe was a perfectly ordered state, then the end of the universe becomes a perfectly chaotic state. And we are headed towards this. This is not speculation. This is metaphysical certainty. 10 to the 100 years, it's not just our civilization that doesn't get that far, but any theoretical civilization cannot make it past this point. Thermodynamics actually forbids it. That 10 to the 100 years seems like an awful long time, right? So maybe, conceptually, it doesn't seem that different from infinity. And so to say that our civilization has to end in 10 to the 100 years, maybe it doesn't seem that dramatic. But we don't actually have to wait that long. There are things that our civilization cannot survive before then. For example, our sun is currently burning out. In about 5.5 billion years from now, the hydrogen atoms at the core of our sun will have become depleted. So right now, the sun is burning hydrogen by fusing it together to form helium, and that's happening mostly at the center of the sun. The helium is slightly more dense, and so it accrues helium in the middle of it. And in 5.5 billion years, the hydrogen will have completely run out. And at that stage, you begin what's called shell burning. So it's able to start fusing in the outer layers. And that causes the sun to actually swell out, and it also cools it down a little bit. Now, what's interesting is that when it's swelling out, the diameter that we're expecting the sun to grow to is roughly the same as Earth's orbit around the sun, which means that our little planet in 5.5 billion years will actually be engulfed in the sun's hot plasma. There is nothing that we can do as a civilization to protect ourselves against an event like this one. At the very least, you would probably have to move the planet far away or get the civilization off the planet and move it far away. But for reasons that I'm not necessarily going to be diving into here, I don't think that those are necessarily plausible at any point in our technological future. Now, 5.5 billion years still seems like a long time, but we don't have to wait that long either. The sun is actually getting brighter every single day. It grows at about, the brightness grows at a rate of about 5% every 100,000 years. So in about 1.1 billion years, the amount of energy that's arriving on the surface of our planet every day from the sun will be too great for the Earth to be able to hold on to its oceans anymore. So this will turn Earth basically into a giant desert. Since almost all cellular life, or actually all cellular life on Earth is dependent on the presence of water, of liquid water, this is a mass sterilization event. It's possible that there might be some extremophiles that live deep in the Earth's crust, like the chemotrophs, that could survive something like this, but no civilization can possibly withstand this. There is no overcoming it. Notice that we've already gone from 10 to the 100 years down to about 1 billion years. So we're starting to get a little bit closer to home, maybe, although still 1 billion years seems like it's pretty far away. But our civilization doesn't have to wait that long either before I'm convinced that it's going to face its demise. One of the biggest challenges that we're facing is global warming. And I know that in certain circles, this is still a contentious topic, but please rest assured that this is not a topic of scientific debate. The data is clear, but what is perhaps a speculative topic is what global warming means for our civilization. We know what it's doing. We know how bad it is. What we don't know is how bad it's going to be for us necessarily. But I have looked into it and I've got some interesting data that I'd like to share with you. One is that there is an adaptability limit to climate change. What does this mean? If you take an animal and you put it in a situation, put it in an environment where the humidity and the temperature is at a certain level, you can actually take away that animal's ability to exchange its body heat with the environment. Do you remember this picture? Where I had a hot object and a cold object, and eventually they reach the same temperature, but after they're the same temperature, they can no longer exchange thermal energy between them. Well, in about 300 to 500 years from now, the Earth will be at such a temperature that you can no longer lose body heat through sweating. And believe it or not, this level, this temperature and humidity requirement, where that body heat exchange is no longer possible, is the same for almost all plants and animals. So almost all scientists have, sorry, not almost all scientists, almost all environmental scientists at one stage have had to consider what the long-term impact of climate change is going to be for our civilization. But some of the more, let's say, generalists have been thinking about, well, what's the impact of climate change going to be for life on the planet? And it looks like this is not a ridiculous estimate for what is going to be the end of all cellular life on the planet due to global warming. And 300 to 500 years is a lot less than 10 to the 100. We don't have to wait that long either. Infection is almost incurable. I've taken this video clip from Howie's lab, which is a YouTube channel. Feel free to check it out after this presentation. And what's happened here is I think he's swabbed his mouth or his skin, and he's put it under a microscope slide, and you can see these little things wriggling around in there. So those tiny little microscopic organisms, some of them are bacteria, some might be fungus. But these are the things that are kind of driving your body around. To something of an approximation, a human is kind of like a giant Gundam robot that bacteria fly around, right? They use to kind of navigate their environment. There are more bacterial genes inside a human than there are human genes. Since the 1940s, we've started this trend where we mass produce antibiotics and we force feed it to ourselves, we spread it through the environment, we feed it to our livestock. And over time, we've noticed that those bacteria are getting more and more resilient to those drugs that we use to defend ourselves when we get sick. Now, it was once thought that this would be something that we can just constantly address as it comes up. So antibiotics resistance is nothing new. Penicillin resistance was noticed, I think, as little as 1 year after penicillin was first discovered. But what is new is the idea that we may get to some innovation frontier that we never quite get over, where we can no longer produce new drugs at a fast enough rate to be able to treat infections as they are discovered. So this has been sort of a bona fide public health crisis since at least the early 90s. By the year 2000, I would say that it was even mainstream knowledge that superbugs, things like golden staph, were going to be a huge problem. And you actually don't have to conduct a very thorough survey to find someone who has had a family member or a friend who's probably gone into hospital for some minor surgery and ended up dying of something like a staph infection that was incurable because the antibiotics, there are no antibiotics available to fight it. That is a new thing. Back in the 1960s, there were no infections that did this. This is something that is getting worse over time, and it's continuing to get worse. We're not doing anything to stop it. More interestingly, these antibiotic-resistant infections, they tend to track with temperature. So not only is our civilization not really managing to fight these things, in any meaningful sense, it seems that we're actually producing an environment that's more conducive to resistant bacteria as we go. So global warming is actually exacerbating this issue at the same time. We also used to think that antibiotics resistance was something that humans created, that antibiotics are fundamentally artificial, and that by producing these and spreading them into the environment, that we somehow produced antibiotic resistant bacteria. This is actually not true at all. Most antibiotics, especially the penicillins and all of that family of antimicrobial products, they are based on natural analogs, right? The penicillin compound, the first one, was actually discovered in blue mold. And so it's actually been at a non-zero level in the environment for millennia. And so there was already a very large ancient reservoir of antimicrobial resistance genes that we selected for and amplified. So it's almost like there was this sleeping giant, and we just stoked it, right? We just woke it up, and it's now that giant that we're now wrestling with. So you would think that in light of this knowledge, that we would be in a good position to do something about it. But unfortunately, there's actually a huge amount of red tape and regulatory resistance that we're fighting at the same time. So the Infectious Diseases Society of America has been extremely well organized, in my opinion, in lobbying Congress with proposed legislation and policy that would actually allow for antimicrobial resistance to be, at least managed, if not solved, and it present basically a roadmap for us being able to deal with this long term. Some of their essays, and some of them are really excellent, I really suggest reading these, say that basically they have approached Congress with really well thought out policy on a very large number of occasions. However, it's mostly been ignored. And this is a really bad thing, because the reason you have something like the Infectious Diseases Society of America is because you entrust them, the experts, with being able to manage public health policy. And this has been at the top of their priorities list since at least the early 2000s. And basically no legislative action has ever been passed. And they're beginning to suspect that no legislative interventions will ever be passed. And what might be worse than this is that the majority of the public doesn't even seem to know that antimicrobial resistance is a big problem. Well, now you know. My purpose now is to try and inform you so that you have the ability to make good decisions. I don't really want to end this presentation on such a bad note though. I know that this is very doom and gloom, and maybe I've given you some new perspective. And it's not always pleasant to have your worldview shaken up, and that's okay. But it's worth asking, why I would do this. Why, even during a pandemic, would I show you some stuff that I think is going to, ruin your whole week? I don't think that being ignorant of this type of information is ever advantageous. I think that you need to have the right information at your disposal, and you need to understand it and be able to process it, so that when someone asks you how you feel about some leader that's being elected or some policy that's under consideration, that you are in the best possible position to decide how you feel about it. I think if you didn't know some of these things, then you wouldn't necessarily be speaking from an authoritarian position in developing an opinion on those. But before we conclude, I also just want to show you this picture. Existential dread is a real thing, and it can be deeply unpleasant, but there is also a way out of it, and that's try not to dwell on any of the things that I've told you right now. There are some things that we are absolutely hopeless to fight. The heat death of the universe is coming, and it is 10 to the 100 years away, but that doesn't matter. This doesn't affect your life or impact your life in any meaningful way. what might impact your life in a meaningful way is things like cute animals. You know, this is a valid reason to be happy. And if these things give you joy, then just enjoy those things, and that's totally fine. So, you know, I hope that you found this presentation, you know, enjoyable, and I'm happy to leave it on a positive note.
Everybody loves cute puppies. My cat is running around down the carpet right now, so way to bring it all the way around to cats on the internet. All right, so we got a couple of questions. Doris, if you're sorry, Doris, I didn't. Sorry, I will back off. Doris, these are your questions.
All good, no worries. Thank you so much, Mark. We have a question from Karen Emery, who asked, how is it known when the universe started to become chaotic?
Yeah, that's a very, very good question. And I would say that the accuracy to which we know that number is, in my opinion, still debatable. There are some particle physicists that are going to tell you that actually, no, we know it down to 1/12 of, you know, a second, or even, you know, 12 millionths of a second. But the short answer is that you can see how things are spreading out now. So imagine that you walk in halfway through an animation of a circle that's expanding on a screen, okay? And you sit down and you watch it for days, right? And the rate of the change that you see in that image is the same over that entire time period. What physicists do now is that they look at those types of things and they extrapolate, well, I wonder if we ran it in reverse, how long would it take for it to collapse on itself? And so that's kind of, you know, that's a massive oversimplification, but I hope that that kind of gives you an idea of the type of reasoning that goes into making these estimates.
Thanks, Mark. And maybe one question from myself. Now, given the heaviness of what you shared with us today, Mark, and if it's not too personal, can you share with us what gets you out of bed each day to do the work that you do?
Yeah, sure. So I'm not disturbed by the idea that our civilization might end. My life has meaning, even though my life is impermanent and our species is impermanent. I still enjoy things like cinema and music. I enjoy, you know, eating great food, and all of those things are worth doing, even if, you know, it all comes to an end one day. And I don't see how it all coming to an end one day has to impact on my enjoyment of the things that I do now.
And one last question that's snuck in from Kylie Ana Fuentes. We've heard a theory that when we get to heat death, that time would go in reverse. Do you have any insights on this?
Yeah, so time becomes meaningless at heat death, but it's actually still there. So on a macro scale, after heat death, there are things still there, right? There are still going to be iron atoms diffusing around, bouncing off of each other and things like that. So if you were to shrink down and take a very small sample of the universe at that point, you would see that actually the clock is still running because those atoms still need to interact. But as you zoom out, everything kind of averages out. And so it looks like the clock has stopped. So actually, I'm not familiar with the theory that time would start running in reverse. There is something called the Poincaré recursion time, which has to do with how long it would take for a system the size of the universe with particles diffusing about by Brownian random motion, how long it would take from one state to explore all other states and then by chance diffuse back to its starting state. And that's one of the largest numbers that was ever used in a form of proof. I think that's 100 to the 10 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 or something ridiculous. But it's important to realize that even when you're dealing with Poincaré recurrence, that the atoms themselves are still moving forwards in time. If you start with a whole bunch of iron and then do a Poincaré recurrence, you still have nothing but iron at the end. So I think that there may be a misinterpretation of that idea that makes it sound like time is running in reverse. But if there is a much more direct time will run in reverse hypothesis, I'm not familiar enough with it to comment.
And I think we've just gone a little bit past our time. Thank you so much, Mark, for your presentation. That's it from Melbourne, Australia today. Back to you, Matt.
Great. Thanks so much for giving us part of your morning. I guess we should call this nerd morning instead of nerd night for all of you. So thank you. And hopefully your Monday is going swelly at this point. All right. So Crystal, Matthew, go ahead and fire up your webcams and your mics. I want to pass this over to the good folks at Nerd Night North Vancouver, not to be confused, of course, with Nerd Night regular Vancouver. We're going to talk a little bit now about what it was like to be inspired by a space shuttle Atlantis. And Matthew, if I can get this right, there were 6 space shuttles, Atlantis, Enterprise, Endeavour, Discovery, Challenger, and Columbia.
Yeah, that was great. I'm glad you remembered them all because I wasn't sure if on the spot I would.
Great. I'm glad you, I set them up, you knock them down. All right.
Thank you.
Go ahead, take it away.
Hey guys. Okay, what's happening, guys? Where's my video feed?
It is on our computers.
Are you guys seeing me? We're good to go?
Yeah, you're all good.
Oh, excellent. Okay, so ta-da, I'm Crystal, host of Nerd Night North Fan, or Nerd Night Vancouver, the light version. And tonight we're here with Matt Cimone. He's a really good friend of the show, and he is a science communicator here in Vancouver. He's a science interpreter at the Trotty Observatory at SFU and at our local H.R. McMillan Space Center. He started his own nonprofit in 2012 to bring education to women in South Africa. When he's not doing that, he's working on his documentary film about the final launch of the space shuttle. And it has amazing interviews with super nerds like Bill Nye and Jill Tarter and like practically every Star Trek actor. And yeah, despite all of that work, he's still waiting for his letter of acceptance from Starfleet Academy. And now he's going to tell us about his childhood dream of becoming an astronaut. There you go.
All right. Thanks, everyone. All right, I'll get, if I screen share properly, I'll make this work. Ta-da. All right, is my Prezi on? Did that work? Okay, hopefully it did. All right, so hi, everyone. My name's Matthew, and like many of you, I had a childhood dream of becoming an astronaut. Where that came from was originally with my grandfather. So this is a photo of my grandfather and I. If you can't tell, I'm the one standing on the right. And this is the dock at his cottage at Shibanawan Lake in northwestern Ontario. And my grandfather had this amazing little 60mm telescope. It probably cost $100 at like Canadian Tire or something like that. And it was wobbly, but we would look through the stars at it and we'd look through the rings of Saturn. I remember seeing Jupiter through the first time with it, and a lot of my nights were spent that way with him when I was a kid. But there was one night in particular that really stands out for me. My grandfather was standing on the dock, and we turned around, and he pointed to this like fuzzy patch in the clouds, or fuzzy patch that almost looked like a cloud above our cottage. And he said to me, he's like, "That's not a star or a cloud. It's actually the light of the Andromeda galaxy." And Andromeda is the largest object that a human being can see with the naked eye. And he was telling me that I'm actually seeing the light of billions of stars that has been traveling through space for millions of years before it arrived in your eye. And it was the first moment that I have a clear memory of feeling a sense of wonder and awe about the universe. And it stuck with me and basically defined like the whole rest of my life. I decided from that moment on that I wanted to be an astronaut. In addition to the inspiration from my grandfather, of course, there was Star Trek. And so I'd watched the movies, original series movies growing up, and of course was starting to watch Next Generation in 1987 when I was like 6 years old. So between that and my grandfather's inspiration, of course, I wanted to go to space. Of course, this is not actually me as an astronaut. This is my head stuck on Chris Hadfield, who is actually my favorite astronaut. And one of the reasons why I really appreciated Chris was that he talked about going to space in terms of the human experience. So it wasn't just like space is out there, but it was like, what do I see when I look back toward the planet? And one of the things I remember him saying in particular is that when you see the atmosphere of the planet, it's like Other astronauts had described it as being like the skin of an orange, but he said it's a lot more like the skin of an onion. It's very thin and reflecting on the preciousness and fragility of our own planet. Unfortunately, however, that dream didn't work out for a number of reasons. One, it turns out that while I really love science and mathematics, I'm really bad at doing science and mathematics. Secondly, at the time, one of the ways that I thought I could go on the path to becoming an astronaut was similar to Chris, was becoming an Air Force pilot. And unfortunately at the time, and this might have changed recently, but you couldn't have corrected vision. You had to have like natural 20/20 vision, except I didn't know that until like high school university day, where this guy named Admiral Jarvis, who was a representative of Royal Military College, showed up at our high school when universities were representing and coming to schools to do recruiting. And I would go running up to this dude, and I've got my whole like life dream from childhood that I've been working on like selling to people. And I want to give him this pitch and be like, Admiral Jarvis, I'm going to become a pilot and go to space like my astronaut idol, Chris Hadfield. And I remember he just kind of looked at me and he was like, what about your eyes? And I was like, no problem, because since the military is going to pay for me to go to school, I can save the money and use it to get laser eye surgery. And he was like, sorry, son, you have to have natural 20/20 vision. And in that moment, this man like crushed my dreams. Look at him there smiling away as he crushed my dreams. In fairness to this guy, I don't actually know who this is. It was the only picture that I could find of an Air Force general. So there you go. Okay. Moving on. So what happened? Like years went by. I ended up like thinking, well, if I can't travel up into space, then maybe I can travel out into the world. And I still wanted to be an explorer. I still wanted to experience like different cultures, different societies. So I ended up actually studying international development at the University of Toronto, ended up abroad. I met a woman in West Africa named Esther Kanu, and we started a project to support her in her school. And so my life seemed to be going very much in like a terrestrial direction. And that was until 2011, when I heard the announcement that the final flight of the space shuttle was happening. And I was blown away by that because first of all, I didn't know the program was ending. But secondly, I used to be so in tune with the space program. I couldn't believe that something like that was coming to pass, and I had no idea. It was a recognition for me of like how disconnected from the program I actually had been. And I had, up until that point, even though that was the vehicle of my childhood dreams, I wanted to be an astronaut on the space shuttle, I realized that like I had never seen a launch, but the whole lifetime of the space shuttle program, and I'd never been in person to see one of the launches. And so I made a point, I was like, I'm going to go and see that last launch of the space shuttle, which was Space Shuttle Atlantis. And I was telling the idea to a friend of mine, Paul, who's here in this picture. And Paul actually graduated from film school. This is Paul Muzzin, who started Riptide Studios. And he graduated from Sheridan College. And Paul was like, well, like, how are you gonna like document it? And at the time, I hadn't thought about that as much. I was like, well, I'm going to bring a big convoy of people because I wanted to share the experience with as many people as possible. But I was starting to think about the fact that the best way to do that might be to bring a camera. And Paul said, well, if you're going to do that, like do it properly. Let's get proper film gear, and I will come along with you and I'll shoot it. And so we started shooting this road trip film. And we wrote on the back of the car, we're like STS-135, which was the name of the mission, or bust. We put together a website, it was like chasingatlantis.com, and it was just two guys who had like never really made a feature-length film before or any kind of documentary project, or even was thinking about it being feature-length at this point. And we were like, let's head down. And it was amazing. Like there was 1 million people showed up for the launch, actually 1 million people in Titusville, Florida, which normally has a population of like 10,000 people. And everyone was tented, like camped out on the shores. And we weren't sure at first if it was actually going to launch because the weather didn't look very good. And the space shuttle can't actually launch through rain because it goes so quickly before it breaches the atmosphere that raindrops, like any rain particles, will actually tear through the space shuttle. They'll rip the outer layers of the shuttle right off. And so right up until that morning, it was raining. The launch was supposed to happen at 10:21. We woke up sleeping in tents that morning, and we're just waiting. People are crowded around radios, like sitting on the shore, just like looking at the shuttle. It's about, it's about 10 kilometers away. And all of a sudden at about 10 o'clock, this like clearing opened up in the sky right above the shuttle, just like this holy light, almost like shining down on the place. And we all heard on the radio, it was like, Atlantis, you are go for launch. And everyone like this rumbling across all this 1 million people. And so together, this whole crowd of 1 million folk, like 4 people wide, and then along the shore, as far as you can see in both directions, all counting down 10, 9, 8, 7, 6, 5, and then all of a sudden it's like already going into the air because there's a radio delay, and we're like, oh, 4, 3, 2, 1, yay, right? And this thing takes off into the air, lifting up 4 of the last astronauts on the space shuttle, and all of this group of humanity watching them go together and cheering. And we were like, okay, well, we did it. We drove down, we watched the launch, we got the footage, and I guess we're done. And as the contrail here, the smoke from the shuttle was kind of disappearing into the atmosphere, my phone started ringing, and I figured it was family members who wanted to connect with me because we had gone down there. But it wasn't. It was actually the Canadian Space Agency, because what had happened was on the way down, just on the off chance it might happen, I sent them an email and I was like, hey, listen, there's a couple of us Canadians, we're heading down to see this launch. Would it be possible to interview an astronaut? And they were like, well, how about interviewing Chris Hadfield? And we were like, well, yeah. So all of a sudden I had this opportunity now to like connect with my childhood astronaut idol and talk to him about space. And I got to ask him the question, which kind of started all of a sudden leading us into what the project ended up evolving into. It was like, what happens if it doesn't work out? You know, obviously he wants to inspire a future generation of other astronauts, but he's like, you know, what happens if it doesn't work out? And he's like, well, you can't just stay still. You can't just like dwell on the thing. You have to find another way to take your skills and talents and move in a different direction. And he's like, you have to remember, when I became a pilot, he's like, it wasn't my dream to go off and become the space station commander, because that's what he was about to do in a couple of years. He's like, I just went step by step and like sought after things I was interested in and passionate about. And then my career ended up in this direction. But he's like, that's not what I had set out to do initially. And I was like, okay, so now what do? I was like, I just literally watched my childhood dream fly away into space. And, you know, I wasn't really like completely satisfied with where I was at with my own life, because I'd realized that there was this big part of me that shaped my childhood that I had no contact with anymore. You know, it might as well have been that shuttle that was 10 kilometers away flying off into space. So then we thought, well, maybe we can talk to more people about this. And all of a sudden we had the makings of what was, you know, going to become a documentary. We started thinking of people we could talk to about space exploration, about career, about taking risk. And we started thinking, well, who are like some of the biggest people that shaped us, and see if they'd be willing to talk to us. So one of them was this, a person that we really wanted to talk to, and I was on the phone with their agent. Her name was Betsy. And so we asked for a quote for this one particular interview, and she was like, it's going to cost $50,000. And we're like, wow, that's more money than we'd spent on the entire project. We'd already been doing it for a few years at this point. And I was like, well, okay, we can't pay $50,000. And then she was like, okay, how about $10,000? And I was like, how about $1,000? Because that's all I think we'd be able to pay. And then she was like, that's a $49,000 discount. Let me ask him and I'll get back to you. So I hung up the phone. I'm like, there's no way I'm going to hear from this woman anymore. And then she calls me back, or I got a call back on the phone. It was her number, but it was actually the person she represents, which is Bill Nye, the science guy. So Bill Nye calls me and he was like, Matt, he's like, tell me about your film. And, you know, also they tell you like, you know, there's times you have to give like a legit elevator pitch. And all of a sudden I was like, I have to give an elevator pitch to Bill Nye. So I said to him, I was like, imagine the children that you raised as like, you know, your science kids have now grown up and want to talk to you about the future of the space program and the retirement of the space shuttle. And he was like, okay, we'll do it. But you have to come down here to the Planetary Society in California. And we're like, well, yeah, of course. And you kind of make it out here in the picture, but he's wearing a tie. We made a bow tie for him because, you know, what do you get Bill Nye as a gift? It's going to be obviously a bow tie. And we had the logo for our film printed on it. And so we gave it to him. And while I was trying to get it made, I actually I didn't know anything about bow ties or like I was like, apparently there's more than one style. So I phoned this place in Vermont. It was one of the first places I could find on Google that made custom bow ties. And I told them that we were going to send them the fabric. And they were like, well, what size do you need and what style? And I was like, I don't know. And I didn't want to name drop or anything, but I was like, well, it's for Bill Nye. And then she says, well, we make all of his ties. And I was like, what are the odds of that happening? Right? There's these times where sometimes I think when you're bold, I think things try to start to fall into place for you a little bit. Some other great interviews we did. So we talked to, this is Gene Roddenberry's son, Rod Roddenberry, who interviewed. This is at the Las Vegas Star Trek convention, and there was like a set that looked like the original Enterprise. So we got to like interview Rod on the bridge of the Enterprise, talking about his dad and how like Rod has taken up some of the mantle of Star Trek, and he's really tied into the fan community super well. So it's like really cool. And then we got to have these kind of full circle moments that started happening along the theme of the space program. After 4 years of knocking on the door at the Kennedy Space Center, they finally let us get in for some private time with Atlantis that has been converted now into this facility that's like a museum for the space shuttle program. And so if you're ever down, whenever that happens to be again, like down in the US, and you have a chance to see this thing, it's amazing. The shuttle is way larger than you'd ever think it is, because it's like, we're always seeing it from so far away. When you're up close to it, it's enormous. So we got to do that, which was really cool. We also had the opportunity to film at the new observatory up at Simon Fraser University. We documented its construction, so kind of tying into some of the space program locally, and got to interview Dr. Howard Trottier, who built the observatory, which was really neat. And that was a chance for me to reconnect with like telescopes and stuff in my life, because I hadn't really used one since I was a child, and I got to be involved with the observatory itself up at SFU, where I now work. And kind of like a full moment or full circle moment in terms of audiences and looking at space. We've shot the 2017 solar eclipse, total solar eclipse. We were down in Madras, Oregon. And I don't know if you've ever seen a total solar eclipse, you need to go. There's going to be one on the East Coast, I think in 2024. But we're standing there and like, you're literally in the shadow of the moon. Like, and you see stars in the daytime and everything goes dark and like birds change and crickets come out and as that last little vestige of sunlight is disappearing, all the shadows on the ground start to dance and move around, because you're literally looking at just one twinkling bit of sunlight that's illuminating everything. And whereas with Atlantis, which kind of started our project, was us like looking at humanity reaching up to space, this was like space reaching down to us. And same thing, it was a crowd of like almost 1 million people that were there all in the shadow of the moon. And it was just like astonishing. There's a picture through my telescope of the last moments, just as like the moon is about to occlude the sun. We also have this really cool thing where, like I was thinking about as a kid, like, being a fan of Star Trek, all of a sudden one day a friend of mine happened to be on the StarTrek.com website and was like, hey, did you guys know that there's like a thing about you on the StarTrek.com website? And we're like, what? Because there were a number of Star Trek people that we had interviewed. And so StarTrek.com actually did a story on us. And the cool thing about this story is that it ran on July 14th, which is actually my grandfather's birthday. So it was kind of like another one of these cool sort of connection moments for us. But also like the film started to evolve a lot. And we started realizing that this project wasn't so much about a space shuttle anymore. It wasn't about just like the space program. It started becoming a lot more about less about the what of space, but of the why. Like why was I still so tied to this like story of space this late in my life, and why had it shaped me so much as a kid? And I started getting like some sense of that it was really about the family. It was about the fans. It was about the community that was around space, and that connection that people found in the stories about space. When you think about it, like so many stories in science fiction are really about family. They're about belonging. They're about connection. And I got that too when one of the interviews that we did was with Will Wheaton. And we were asking everyone like, what is about space that you find so interesting? And most people would talk about like black holes and planets and sort of the immensity of space. And he said, well, space is the place you want to go when you feel like you don't fit in on Earth, as a kid, especially. And I was like, wow, maybe that's the story we're telling. It's not so much a story that's just about science and technology, but it's really about belonging. And the more that we started interviewing people, the more people would talk about space as a vehicle to discuss belonging, that human need to like connect with each other. So another one of my favorite interviews is with Anne LeMay. She was a writer on the video game series called Mass Effect. And same thing, like when we talked to her, like, why are you a science fiction writer? Because we started talking to writers, not just engineers. And they said the same thing. I use space as a backdrop to talk about belonging. When we're talking about aliens, when we're talking about other civilizations, it's about us trying to talk about humanity. Anne went to work at Ubisoft, and then she's now at Warner Brothers Games. She's helped with the latest Batman game that just came out, which is super cool. A few other people we interviewed, just Bobak Fedorzy, who works at JPL. He's also known as the Mohawk guy. You can see his t-shirt. Clearly, we're all immigrants in outer space. Say that sentiment of belonging. There's Rekha Sharma is over on the right, who's from Battlestar Galactica. She talked about the need of all of us to just like create one giant Starfleet, to be in family with one another. Michelle Specht on the bottom, who's in Star Trek Continues and one of the voices on Star Trek Online. And same thing, just talking about like the reason why I wanted to star in science fiction was because we get to talk about these kinds of topics about connectivity and belonging and just the nature of humanity with one another. And probably the person who I think whose scientific work represented that the best, and I'm just about to wrap up here, but this is Dr. Jill Tarter. She was the founder of the Search for Extraterrestrial Intelligence program when we had the opportunity to interview her last summer. And I think like, if there's one person's work who manifests this kind of like need for human connectivity, I mean, as individuals, we all ask like, am I alone? Do people understand me? Am I connecting? Am I understood? Well, when we do that as a civilization, that's literally SETI. That's what we're doing. We're like looking up at the sky and wondering like, are we alone? Are we the only life out there? Like, do other people share similar experiences to us as living beings on our own planet? And one of the things she talked about, and kind of bounce off Mark a little bit in this when he was talking about the existential crisis of our life on our planet. One of the reasons she said that she did this work is that if we got an answer, if there was another civilization out there that answered us, and that there ever happened to be, you think about the scale of the universe, if there just happened to be two civilizations that are alive at the same time and they can talk to each other, that means that technological civilizations can be long-lived. They can overcome their issues. And that signal to one another, even if it's just like maybe a string of prime numbers, whatever, is still someone else saying, hey, we're alive. And if you're alive too and you're listening to this, I mean, maybe we made it. We've both existed long enough to be able to have communication across the distances. So for her, listening for that signal was a sense of hope for that we could survive. We could overcome our issues and we could make it as a civilization. This is one of the dishes at the SETI Institute, listening to the stars. And of course, coming back to that conversation around family, probably the most important interview we did was to go back and talk to my grandfather again. So this is that same doc all these years later. We went and found that old telescope and we set it up together, looking out. There's he and I. I'm still the one on the right on the photo, if you can't tell. And thinking back to that Andromeda galaxy, that kind of thing that set it off for me to start with, well, using the big telescope at the observatory, I was able to take an image of it. So this is a close-up picture of Andromeda and give it to my grandfather. So now he's got a photo of it at his house, kind of a reminder of the journey he sent me on. And there it is. There's that telescope. We're now at work, right? And so I was able to transition my career through the course of doing this. And that's kind of the point of what I wanted to talk about, is that I think it is possible for you to reconnect with a childhood passion later on in your life. I left Simon Fraser University where I was working. Now I work at the planetarium, and we can't go inside of it anymore right now. So then I had to figure out, well, now that there's been closure due to COVID, I've started writing for a space science magazine called Universe Today, because that was my way to still say, hey, even in light of this, with the disconnection from one another, how can I still be connected to this thing that I'm passionate about? So this was a work from home option that I was able to connect with. And so this picture that I showed at the beginning is actually a drawing from a friend of mine named Ellie Tornblom, and she's a designer. It's called Frosticular Design. And what she does is she takes drawings that are made by her child and then redraws them as her adult self. And when I saw this picture, I was like, oh my goodness, that's exactly what I've been trying to do. We've got this vision of like a childhood dream. And of course, like our career choices when we're, 8 or whatever are not really thought out that well. But sometimes we can come back to them. We have all this new experience and these skills. And so I would say, like, if there is something that you've been passionate about, like, find out that what. And find out if there's any way to reconnect with it again, because there's probably something there that you haven't thought of, that there are opportunities. I will never be an astronaut. I'm never going to go to space, but I was able to make this film and do this work. And in some ways, do everything that I wanted to do as an astronaut anyway, connect with humanity, give us all sort of like, make the stars a little bit closer for all of us, whether it's through a telescope or writing or interviews. And I would also say the why, figure out the why, like what is that thing that you had in the past, but why is that? And ask people that, when someone tells you what they do, or when you ask someone what they're doing, don't just ask the what, but ask the why. Like, why do you do that thing? For me, the what was space. The why ended up being family. That's not what I expected. But that's what I found out. It's space makes me feel connected to people, and that's why I do it. And finally, my last piece of advice is just ask. If there are people that you think might be able to help you with a project, ask for help, because you'd be amazed at how many people were willing to help you out along the way. And that's one of the things that I've been really very grateful and humbled for, is how many people were willing to help us out, even though we were just like, 2 kids from Northern Ontario who'd never made a film, and be willing to be a part of our project. I think I've run out of time. So there we go.
That was perfect. Right on point. So we're right at the end of the show. So I think we're going to end it there because that was perfect. Find a way to connect to your dream. And Matt, we shoot it back to you.
Yeah, thanks. I want to thank everyone. Oh, wait, hold on a second. Sorry, I'm having a bandwidth issue here. Hopefully the bandwidth issue is fighting through. I'm not sure. I'm going to keep talking. Crystal, interrupt me or hop in if something is amiss. I want to thank everyone for joining this. This is, again, the first of 4 different sessions coming up in this month, every Sunday night at 8 Eastern, 5 Pacific, and everywhere in between. We will be doing sessions just like this one. So, also, I guess I want to make a comment that there is going to be I don't know if it's been announced yet, but there is going to be another Star Trek convention coming up in April in Chicago. I think the Las Vegas one might be done. So I may not be spoiling any secrets at this point, but if in case you didn't know, now you know. So keep an eye out for that. Sorry, I can't tell if I can still be heard or not. You know, it's bandwidth thing. So, all right, hey, maybe everything's fine. All right, so in case you didn't hear me, just a couple of things. One, in case I'm not spoiling this for anyone, there is a new Star Trek convention. The Las Vegas one is no longer happening. It's over. Sorry, Star Trek fans. There is a new one happening. It's going to be in April in Chicago. So if you are able to go to a face-to-face event, assuming face-to-face events still happen in 2021, mark your calendar for a Star Trek mission in Chicago in April. Should be something. Again, so we will see all of you back here at 8 o'clock Eastern, 5 o'clock Pacific next Sunday, the 13th, then on Sunday the 20th, then on Sunday the 27th. Again, most of these will be space related. Although I will say, and this is a fun thing I actually recommend for all of you to do this week if you haven't done so yet. The first presentation next Sunday, 8 o'clock Eastern, will be a presentation by Seth Porges, not space related. He holds the record for most unique Nerd Night presentations. He's given 9. And one of them that he gave in 2009 is actually, he turned it into a documentary that premiered on HBO last week. It is still on HBO right now. It's called Class Action Park, about the world's most dangerous amusement park. So check it out if you have an hour and a half. It's a documentary about this crazy water park in northern New Jersey that literally killed multiple people back in the 80s. But it's actually kind of funny and quirky despite the death, although that's a weird juxtaposition that is also critical to the film. So thanks, everyone. Thank you to the good folks from Nerd Night San Diego. Thank you to the good folks from Nerd Night Boca Raton. Thank you to the good folks from Nerd Night Melbourne. Good day to all of you. And thanks to the good folks from Nerd Night North Van. Matthew, thank you for inspiring us. Hopefully that will be some good inspiration for everyone who is now debating with and wrestling with the presentation before years about how we're all going to live in a planet that's going to be swallowed by the sun in 5 billion years. So, you know, inspiration versus eventual doom. That is the balance that we live with here at Nerd Night. So this presentation has been recorded. View it right here at Nerd Night. Sorry, at facebook.com/Nerd Night. And thanks, everyone. We'll see you all next Sunday night. Good evening.
Good stuff, man. Have a good rest of the week. Bye-bye.